In this question it is given that the speed of airflow on the upper and the lower surface of a wing of an aeroplane is v1 and v2 respectively. If A is cross-sectional area of wing and rho is the density of air, then upward lift is. So in this question we are considering there is an aerofoil or wings of an aeroplane. The speed of air on the upper and lower surface of wings are v1 and v2 respectively. So on the upper side take it as velocity is v1 and the lower side take it as velocity is v2. Now we know that velocity in the upper side is more than that of velocity in the lower side, and pressure in the upper side take it as P1 and pressure in the lower side take it as nothing but P2. So as V1 is greater than that of V2, this P2 is going to be greater than that of P1. So the force acting in upward direction, let's say force acting in upward direction is F1, is greater than, or take it as F2, is greater than force acting in downward direction, take it as F1. So RM is to find out what about the value of net force. So we can write that is force acting in upward direction minus force acting in downward direction. And force we can take it as pressure into area. So that is P2 into A minus P1 into A will be the value of net force acting in upward direction. So we can write this as P2 minus P1. P2 minus P1 into A is the value of net force acting on the object. Now over here we need to write the value in terms of pressure, so in terms of velocity. So we can use Bernoulli's theorem. According to Bernoulli's theorem, P1 plus half into rho into V1 square is equal to, over here there will not be that much difference in gravitational potential energy, that's why we are not writing this term. So it is P2 plus half into rho into V2 square. So we can find out what about the value of P2 minus P1. We can write this P2 minus P1 is equal to nothing but half into rho into V1 square minus half into rho into V2 square, or I can write half into rho into V1 square minus V2 square. Now instead of P2 minus P1 we can just put this value over here. So instead of P2 minus P1, if you are writing half into rho into V1 square minus V2 square into A, this is going to give the value of net force acting on the particle in upward direction.